Hello everyone and Assalamu alaikum. Welcome to my channel. I'm Ahmed and today we are going to make this video about introduction to sets. So let us not wait anymore and start with today's video. So let's start with today's video, introduction to sets. Starting with the question, what are sets first of all? Okay, let's take the word math. Math. Okay, what's so special about this word? Is there anything special? Well, this word M-A-T-H, these four letters form a word which we call math. And this whole word means our studying math, our math in our education. So this has a group of letters, right? The word math is formed by a group of letters. You have M-A-T-H, these four letters form the word math, and then you call this, the whole thing, the actual math, the educational math that we learn. So sets are something just like this. I know this may be confusing a little bit, but if you try to understand, you can get this. Sets are something just like this. In mathematics, sets are a group of values, a special group of values. Okay, so you can have a defined set of values, right? Say 0, 1, 2, 3, and 4. Okay, let's say these 5 numbers, we can call this a set if we want to. It's just a group of things. Just think of set as a box. A set is a box inside which there are different numbers. So if I say that the word math means the set F, okay, let's say math means a set F. So think of F as a box. So this box here, and let me make a better box. So this box here, say this box is the box F. And if you open this box, inside this, you're going to see the letters M, A, T, and H. That is set. A set is a group of distinct values. It should be well defined. Sets shall be well defined collection of objects. So again, for easier thinking, I'm telling you, think of sets as a box. Now, when you go to practical level, you don't think of sets as a box. I'm trying to make you understand what are sets. That's why I'm using a practical example. So you think of sets as a box and you give the box a name, okay? Just think of this. You have a box, you give the box a name, and inside that you have a lot of, say, numbers or values, anything, a group of stuff. That is set. That is a set. So a math is a set of values and it's inside a box. Inside, if you open that box, you're going to see 4 letters M-A-T-H, and that box is called F. I just named it. You can name it anything you want. I just named it F. Okay, so now we understand what are sets. Let's move on to the next topic of sets. So now the next part. Sets can be finite or infinite. Now what do I mean by sets being finite or infinite? Say I just told you think of sets as a box. Now say I told you real numbers from 1 to 10. Okay, now the numbers from 1 to 10, I want you to make a list of all the numbers from 1 to 10 and then name that set N. Let's say we will name that set N. Okay, let's make a set. So the set's name we told to be N equals to, now this is how you write sets. You write them in braces. So you have braces like this, curly braces. Write all the components or the elements. The members, yes, this is something important. The members of each set, so the members of this set N is 1, 2, 3, 4, 5. Now, these are the 10 numbers that I told. I wanted all the numbers, including 1 and 10, from 1 to 10, right? And I told you to name that set n. So this is how you make a set. You use curly braces, so here as you can see these curly braces, and inside these you write your elements. So you call each and every member of a set an element. Okay? So if somebody asks you what is an element of a set, the element of a set are each and every member of that set. So 1 is the element of the set n, 2 is the element of the set n, 3 is the element of the set n, and so on, so on. So that is an element. Now, what are finite sets or infinite sets? Here, I told you to make a set from 1 to 10. Let's take another example so that we can understand. Say I want you to make a set from 1 to 5. Okay, I just made it half, that's all. And I want you to name that set numbers, or set n. Again, set n. Okay, so you say n equals to curly braces 1, 2, 3, 4, 5. That's curly brace. Now if I ask you, is 3 an element of n? You say yes, 3 is a member or an element of the set n. Now, is this set finite or is it infinite? This is a finite set. Why? Let me try to make you understand this in a simple language. This has a limit until which you stop. You start from the number 1 and then you stop at the number 5. Okay? So you made a set which has a start and a stop. Okay, I'm trying to make this simple language to you. You made a set which has a start, which is 1, and has a finishing line, which is 5. That's why this is a finite set. This has an ending. Now, what are infinite sets? Infinite sets say I want you to make a set of all the numbers. So you start from 1. I say you to start from 1 and then go all the way to infinity. Just keep going. And I want you to name that set I. I'm just picking random letters. Set I. I want you to name that set I. So you'll be like, okay, you want me to do that? So you let me erase this. So I told you, I want you to start from the number 1 and then just keep going. So what will you do? I want you to name it I. So you say set I equals to curly braces. And then what you do, you start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How long will you go? 11, 12. How long will you go? The numbers will never finish. You go billion, million, zillion, trillion. It will never finish. Numbers are numbers. They will never ever finish. This is an infinite set. Here, right here is an infinite set. This is the difference between a finite set and an infinite set. This has an ending. It will end at 5. That's it. You write 1, 2, 3, 4, 5 and you're done. This is an infinite set. I want you to make a set of all the real numbers. You are like, numbers never end. That is an infinite set. Okay, so here, as you can see, we have an infinite set and it will never end. And usually, shouldn't have done that. Okay, so usually, how we show that it is an infinite set, we put 3 dots after the last number we can write. So we can't go anymore, right? After 12, we can't go anymore. So we put these dots. So normally, we understand these dots as so on and so forth. So this means the same thing in maths. Means so on in the same order. It will keep going. So that is an infinite set. Now we know what are sets, what are elements. So each of these members, each and every one of these members are elements of I. And also, let's pick a random number from this set. Let's say 7. Okay. We know 7 is an element of the set I, right? 7 is a member or an element of this set I. So we note this down with this curly E, showing that 7 is a element or a member of the set I. So with this, we show that 7 is a element or a member of the set I. So if I were to ask you that is 8 an element of set I, you can write it down as like this, a element of set I. And if I were to tell you, is -1 a element of set I, then you would be like I equals to this, you cross the E, showing that it is not an element. So -1 is not an element of I. Okay, now member is much easier to memorize. You can call it a member or element, that's your wish. Now I prefer calling it member, but somehow I got used to saying elements. Okay, now let's move on to the next topic. Okay, the next part is sets has no order and elements don't repeat. Okay, so say I have a set, let's say the set math, the word mathematics. Mathematics. Okay, now I can call this group of letters a set. Now let's say we will name this set, and you need to put commas between sets elements. Say that I want to make this word mathematics a set, and I want to call that set M. Okay, we can do that, that's fine, but elements don't repeat. Here the word M has repeated twice, A has repeated twice, and I'm trying to find out in real time. T has repeated twice, H did not repeat, E did not repeat, C and S does not repeat. These three letters M, A, T repeated twice. Elements don't repeat. Okay, so this does not make sense. What makes sense is M, A, T, H, E, and we try not to repeat anything, I, C, S, and this is what a set would make sense. Here this set would make sense because there are no elements repeating. So we can call set M like this. We do not repeat sets. Let's say the set A, C, B, C, D. Here A is repeating twice, C is repeating twice. And if I want to make this distinct group of letters a set, then I would say curly braces A. I would cancel the A's because elements don't repeat. A, C, B, D. And I would be done. And I would call this set something. So I would call this set, say, A. You can name the set whatever you want. So this is an important thing, that in sets, elements don't repeat. Okay. And then the next thing. Say we have a set 1, 3, 4, 6, 9. Okay? And I want to make this group of numbers a set. So basically I would just put them in curly braces. 1, 3, 4, 6, 9, and then equals to, I hate curly braces, equals to, let's say I'll name it set N. Now sets has no order. 1, 3, 4, 6, 9. If I want, I can write it out as 9, 4, 3, 1, 6. It's the same thing. I can write it out as 1, 3, 694. It's the same thing. It's your wish. Set has no order. Okay, let's move on to the next part. Okay, now we have something called the builder's notation. What are builder's notation? We learned about finite and infinite sets. Infinite sets does not have an end. In simple language, it does not have an end. Finite sets, however, sets have an end. Now, well, according to that, if I say you that I want a set which will be called set U, and I want inside that set the elements will be going from 1 all the way to 10,000. Now what are you going to do? You're going to make U equals to, and then you write down, I hate curly braces, and then you write down 1, 2, 3, 4 all the way to 10,000. That can't be done, right? That's where builder's notations come in. Builder's notation, though this is a finite set, it is a very large set. 1 to 10,000. You can't list that big of a number. That is when we use builder's notation. Now let me show you how we use builder's notation. I want you to make a set which will be called U, and it will go from 1 all the way to 10,000, including 1 and 10,000 itself. Okay, so how would you use builder's notation? If I use it, you're going to easily understand it. Let's see. U equals to, again curly braces, as every set you have curly braces to show that this is inside. U equals to X, such that X is greater than or equal to 1, but is smaller than or equal to 10,000. And then curly braces closed. This is builder's notation. We just use the variable X. Now this is builder's notation. You use one single variable to explain a whole thing, and then so here I gave X as our variable. You can choose any variable. I used X as a variable such that X will be greater than or equal to 1, but will be less than or equal to 10,000, and that's it. So this includes all the values from 1 to 10,000, doesn't it? It includes 1 and 10,000 and all the values in between. This X includes 1, 2, 3, 4, 5, 6, 7, 8, everything, right? This is builder's notation. So you don't have to write down 1, 2, 3, 4, 5, 6 all the way to 10,000. You just use builder's notation. You write down one single variable and then define that variable in a certain range. That is builder's notation. Let me show you one more example of builder's notation. Say I want you to make a set which is going to be called something else. Let's say the set is called set N, and the range of the set is going to be from 1 to 1 million. So all you have to do, you write, okay, set N equals to curly braces. You don't forget the curly braces. You write X, or you choose any variable. Let's choose Y. We write Y such that, this straight line means such that Y is greater than or equals to 1, but is less than or equals to 1 million. That just completes one builder's notation. Shows that Y is a value in between this range. That is builder's notation. Okay, let's move on to the next topic. Okay, now we have something called empty sets. We know what are sets. So let's say I have a set called set P, and the elements of set P are nothing. And you're like, what? That is called an empty set. An empty set is a set which does not have any member, does not have any elements, and henceforth, so how do we write elements of a set? We use curly braces, and inside them we write the elements. But this does not have any element. So what do? We leave the element, we leave the braces. This shows that it is an empty set. this is part of sets, and this shows that it is an empty set. That's it. So if you have nothing inside a set, that means it is an empty set. P equals to an empty set. That's it. So you can think of P as a box, and if you open that box, you see nothing. That is an empty set. So another way to note down empty sets are using this symbol, which shows that P equals to nothing. The set P doesn't have any elements. And you can think of the same analogy of the box thing, that if you open it, you see nothing. That is an empty set. Empty sets aren't very hard. Okay, now we know what are empty sets. Let's move on to the next topic. Okay, now we are on to the last part, equal sets, because this is meant to be an introduction and not a whole lecture of sets. This video has already become pretty long. So what are equal sets? It's what the name suggests. It's basically what the name suggests. Say that I have a set which is called set A, and the elements of set A, I'll use builder's notation so that you can understand better. Let's say first notation will be X, such that X is larger than 2 but is smaller than 6. Okay, I'm using simple stuff. Okay, then say you have another set called set B, which also, let's say it does not use builder's notation, but it says the set B has the elements 3, 4, and 5. Okay, now if I evaluate set A, what is the answer that I'm going to get? Values that are larger than 2, that includes 3, 4, and 5. So these 3 values are larger than 2, but they're smaller than 6. Now, do you see anything common? Say we didn't evaluate this part. Okay, say we didn't know. The answer of the set B, if I say what are the elements of set B, you would say that's 3, 4, and 5. And if I asked you evaluate the elements of set A, you would say that's also 3, that's 4, and 5. These two have the same thing. These are equal sets. So you can say A equals to B. That's the same thing. Now, if their elements were not the same, then we would say A is not equals to B. Now that they're same, we say A is equals to B, and this is how we note down equal sets. Okay, so that's it for today. Hope you enjoyed watching my video. If you did learn something, then please don't forget to like, share, and subscribe, and I will see you in the next video.